So what if I asked you to find 9 to the power of 1/2? Well, this is equal to the square root of 9, which is equal to 3. And we're going to look a bit into why taking a number to the power of 1/2 is equal to taking the square root of that number. Now 9 is equal to 3 squared. So 9 to the power of 1/2 can be written in two different ways. Square root of 3 over 3 to the power of 2, or 3 to the power of 2 to the power of 1/2. And in both of these cases, let's look at this one first. The square root cancels out the power of 2, so this is just equal to 3. And in this case, we get 3 to the power of 2 times 1/2. And when we multiply 2 times 1/2, or rather, when we multiply a number by its reciprocal, we get 1. So we get 3 again, because these two cancel out. So either way, we get rid of the power of 2 over here. So that's why when we take a number, let's say x to the power of 1/2, it's the same as taking the square root of x, because they both essentially do the same thing. If x were equal to y squared, both x to the power of 1/2 and square root of x would get rid of that exponent next to the y. So let's go do some examples now. What is 4 to the power of 1/2? Well, we just learned that that is equal to the square root of 4, which is equal to 2. Now what if I asked for 4 to the power of 3.5? Now this is a bit trickier, but we can do this by splitting this fraction up. And we can do that by taking 4 to the power of 1/2 to the power of 3, because this right here would be the same thing as 4 to the power of 1/2 times 3, which is obviously 4 to the power of 3 over 2. So we found out that 4 to the power of 1/2 is equal to 2, so we get 2 to the power of 3, which is equal to 8. Now instead, what if I asked for 27 to the power of 1/3? Now we didn't go over what 1/3 does, but we can find out what it does. So let's find out what it does. 27 is equal to 3 to the power of 3. So 27 to the power of 1/3 is equal to 3 to the power of 3 to the power of 1/3. These two are reciprocals of each other, so they cancel out. So we get 3 to the power of 1, which is equal to 3. And we also see here that the cube root of 27 is equal to 3. So taking x to the power of 1/3 is equivalent to taking the the cube root of x. Using that knowledge, let's find 64 to the power of 1/3. We know that this is the cube root of 64, and 64 is equivalent to 4 to the power of 3. So our answer is 4. Now let's look at something else. 81 to the power of 1/4. Now we're going to have to figure out what this does. We know 81 is equal to 3 to the power of 4. So 81 to the power of 1/4 can be expressed as 3 to the power of 4 to the power of 1 over 4. These two are reciprocals over here, so they cancel out and we get 3. And we also see that the 4th root of 81 is equal to 3. So taking a number x to the power of 1/4 is the same thing as finding its 4th root. And we're noticing a pattern here. If we take x to the power of 1 over n, it's the same thing as looking for the nth root of x. So for example, if we wanted 5 112 to the power of 1/9. This would be the same thing as finding the 9th root of 512. Now 512 is equal to 2 to the power of 9. So we're looking for the 9th root of 2 to the power of 9, which is just 2.